Next lesson is super short. It's just to hammer home again this idea of what you need to have an effective collision. So, a collision between two molecules will only result in a reaction if it's an effective collision. For a collision to be effective, two conditions must be met. Number one, we've now talked about a lot. There must be sufficient energy for a successful collision. What does that mean? The reacting molecules must have enough kinetic energy converted to potential energy to overcome the activation energy. If they do, they may form the activated complex and turn into products. So, making those two connections, right? If you have a kinetic energy distribution like this, where your minimum energy or your activation energy or your threshold energy is this high, you would have this many molecules that would have sufficient energy for successful collision. So, all of these molecules could reach enough potential energy to form the activated complex. Okay? So there's three cases that could happen. Case number one is if the kinetic energy is something, then the potential energy of the activated complex, then the reacting molecules will rebound from each other. What do you think the word there is? So if the kinetic energy is something related to this potential energy of activated complex, okay, it's less than. So if the potential energy or the kinetic energy is less than the activated threshold, right, it will be an ineffective collision and no reaction will occur. Case number two is if the kinetic energy is equal to the potential energy of the activated complex, so you have just enough energy to form the activated complex, then, sorry, my cat is jumping on my stuff, a reaction may or may not occur. And then case number three is if the kinetic energy is more or greater than the potential energy of the activated complex, the molecules become locked together and you'll get an effective collision. So if you have enough energy, so more kinetic energy converted to potential energy, then the molecules should lock together and you will have an effective collision and form an activated complex. But this is only one piece of the puzzle. The other piece of the puzzle, oh my God, sorry, my cat is jumping on my keyboard. The other piece of the puzzle is that the molecules have to come in with favorable geometry. And this is like kind of made out to be a big thing. We'll talk about it here. It could be potentially like a multiple choice question on a test. But the key thing is that if you have molecules that come in with favorable alignment, then the molecules will require less energy for the collision to be effective. So if you look at this example here, this is favorable geometry. Everything is lined up for the reaction to happen, right? So you're going to form these two hydrogen and two bromides are going to form an activated complex easier than this one, which is unfavorable geometry. So these ones would require more energy for the collision to be effective because they're just not coming in quite right. Okay, so it's just a key question. If you look on your worksheet, it'll say something like, which of the following would lead to a successful collision? If there's a chance to choose a question that has and favorable alignment more than just sufficient energy, pick that one. Awesome.